China's goal of 1 hour global travel now seems less like science fiction. A prototype of Beijing's hypersonic jumbo aircraft.
China has revealed a hypersonic aircraft capable of reaching speeds over 4,000 miles per hour.
What is hypersonic technology and why are the Chinese better at it than we are?
Hypersonics is going really fast, so probably about 4,000 miles an hour.
Making global travel possible in under 2 hours. It flies above the atmosphere, reducing drag and fuel consumption, and this completely defies all laws of physics. This breakthrough is rewriting the future of aviation as a giant technological leap that's turning heads worldwide. But how did China bring this idea to life? In this video, we will reveal the new $13 billion aircraft made by China, the creation of the hypersonic jet. China's hypersonic jet, called Enchang No. 1, has become the center of attention in aviation, shaking up the global aerospace scene. This new jet is setting a new benchmark with its advanced design, groundbreaking technology, and unmatched speed, making it clear that the future of air travel is here. The Enchang No. 1 is designed to cruise at Mach 6, which is 6 times the speed of sound. To put it into perspective, the speed of sound, or Mach 1, is approximately 767 miles per hour, which is equivalent to 1,234 kilometers per hour. Multiply that by 6, and you get an impressive 4,600 miles per hour, which equals 7,400 kilometers per hour. At this speed, flights that would typically take hours can now be completed in just minutes. For instance, a journey from New York to London, which currently takes around 7 hours, could be completed in less than 1 hour. This high speed makes it difficult for other aircraft projects to compete, but that is not all there is to this technological advancement. Stay tuned to find out more. The technology driving this jet's speed is its revolutionary engine system, known as the mutter engine. This stands for multi-ducted twin-turbine ejector ramjet. It is not just one type of engine, but a combination of several propulsion systems that work together to make the jet efficient at low speeds and incredibly powerful at high speeds. This design allows the jet to transition smoothly between different flight stages, ensuring stability and efficiency throughout the journey. At lower speeds, the jet uses turbofan engines, which are commonly seen in commercial airplanes. These engines are reliable for takeoff and landing, but as the jet speeds up, it switches to rocket engines to reach supersonic speeds, and then the ramjet engines take over for hypersonic travel. Ramjets are unique because they have no moving parts and rely on the high-speed airflow to compress the air needed for combustion. They become more efficient as the aircraft moves faster, but they can't function at low speeds, which is why the combination of engine types is so important. Developing the mutter engine took years of research, testing, and innovation. Hypersonic engines need to be lightweight, durable, and capable of operating under extreme conditions, especially the intense heat generated at such high speeds. The Enchang No. 1's engineers solved these challenges with advanced computer modeling and small-scale prototypes, refining their designs until they achieved a system that worked seamlessly. The heat generated during hypersonic flight is one of the biggest challenges. At Mach 5 and above, the friction from the air creates temperatures that can exceed 1,500 degrees Celsius. Traditional materials used in aircraft construction can't handle such heat, so advanced materials like ceramic matrix composites are used. These materials are lightweight, heat-resistant, and designed to protect the aircraft's critical components, ensuring safety and structural integrity. The compact and efficient design of the Enchang No. 1 also makes it special. The jet is expected to carry up to 10 passengers, making it ideal for high-speed business trips or luxury travel. While it is smaller than commercial airliners, its focus is on providing fast, direct flights for a select group of passengers. This aligns with the increasing demand for faster travel options in an increasingly connected world. The development of the Enchang No. 1 started in 2019, led by Yin Zhong, a prominent scientist and director of science and technology at the Aero Engine Corporation of China. Yin and his team faced many obstacles, but their dedication to pushing the boundaries of aviation technology has resulted in a jet that is years ahead of its time. Yin has described the project as a major step forward for both technology and global transportation, with the potential to reshape how people think about air travel. China's progress with the Yanchang No. 1 has intensified competition among other countries and private companies. The United States, Russia, and Australia are all working on their own hypersonic projects. In the US, companies like Hermeus and Stratolaunch are developing aircraft with innovative designs and propulsion systems. Russia has also made significant strides, focusing on hypersonic vehicles with military applications. The global race to master hypersonic technology is not just about commercial travel, but also about gaining strategic advantages in defense and aerospace. Hypersonic aircraft like the Yanchang No. 1 are seen as game changers in the military sector. Their extreme speeds make them difficult to detect and intercept, providing an edge in surveillance, reconnaissance, and weapon delivery. For example, hypersonic missiles can bypass traditional defense systems due to their speed and maneuverability, making them a powerful tool for any nation that develops them. In addition to defense, hypersonic technology holds promise for space exploration. Reusable hypersonic vehicles could make launching satellites or other payloads into space more efficient and cost-effective. The ability to travel at such high speeds could revolutionize how we access and explore space, opening the door to new opportunities for research and commercial ventures. The Yanchang No. 1 has also drawn comparisons to the Concorde, the legendary supersonic jet that operated from 1976 to 2003. The Concorde had a top speed of Mach 2.04, or about 2,179 kilometers per hour, which was groundbreaking at the time, but the Concorde's retirement left a gap in the market for high-speed air travel. Advances in technology have now made it possible to surpass the Concorde's capabilities, and the Yanchang No. 1 is leading the way. While the Concorde was limited by its reliance on traditional jet engines and the challenges of sonic booms, the Yanchang No. 1's advanced propulsion system and design address these issues. Sonic booms, which occur when an aircraft breaks the sound barrier, have been a barrier to supersonic and hypersonic travel, especially over land. Efforts to reduce or eliminate sonic booms are part of ongoing research, with projects like NASA's X-59 aiming to make high-speed air travel more accessible. Countries in support of the creation of the hypersonic jet. The race for hypersonic technology is heating up, and China's Yanchang No. 1 project has caught the attention of the world. While China leads the charge, other countries and organizations are also diving into hypersonic research, each bringing their own strategies to the table. From Europe to India and beyond, the push for faster, more efficient travel is reshaping the aerospace industry. Europe is making strides in hypersonic innovation with projects like the French VMAX, short for Vehicle Maneuvering Experimental. This ambitious initiative focuses on creating hypersonic weapons and aircraft that could rival some of the most advanced systems in the world. France sees this as a strategic step forward, aiming to strengthen its defense capabilities while contributing to the global development of next-generation aviation. India has also joined the hypersonic race with its Hypersonic Technology Demonstrator Vehicle. This program is a significant part of India's effort to build hypersonic missiles for its military. The country has made notable progress, successfully testing the technology and achieving key milestones. This project is seen as a critical piece of India's Make in India initiative, which focuses on boosting domestic innovation and reducing reliance on foreign technology. In the United States, private companies and government agencies are pushing the boundaries of hypersonic research. Firms like Hermeus and Stratolaunch are working on hypersonic vehicles for both civilian and military use. Hermeus, for instance, is developing a passenger jet that could cut travel times dramatically, while Stratolaunch is focusing on platforms that support hypersonic testing. On the government side, NASA and the Defense Advanced Research Projects Agency are leading efforts to overcome the technical challenges of hypersonic flight. NASA's X-59, designed to reduce the disruptive sonic boom, is an example of how engineers are trying to address issues that have plagued supersonic and hypersonic aircraft for decades. Russia is another major player, making significant advancements in hypersonic technology. The country's avant-garde hypersonic glide vehicle, capable of reaching speeds exceeding Mach 20, is one of the fastest systems ever developed. Russia has also created the Kinzhal missile, which can travel at Mach 10 and be launched from fighter jets. These developments highlight how seriously Russia is taking the hypersonic challenge, particularly for military purposes. While these countries and organizations are investing heavily in hypersonic systems, the challenges remain daunting. Developing a hypersonic jet that is both reliable and cost-effective requires massive investment in materials, propulsion systems, and cooling technology. The high temperatures generated at these speeds can reach over 1,500 degrees Celsius, pushing traditional materials far beyond their limits. Engineers are exploring advanced materials like ceramic composites to handle the extreme heat, but these solutions are still incredibly expensive. Noise pollution is another issue. The sonic boom produced by breaking the sound barrier has led to bans on supersonic flight over land in the past. Hypersonic jets face even greater challenges with noise, as their booms are louder and more disruptive. NASA's X-59 project aims to reduce this problem, but applying such technology to hypersonic speeds is an entirely new challenge. Why certain countries reject the hypersonic jet? Countries with strict rules about noise pollution are unlikely to allow hypersonic jets like China's Enchang No. 1 to operate in their airspace. These jets generate a sonic boom that is much louder than what supersonic aircraft like the Concorde created. When a plane breaks the sound barrier, it sends out a shock wave that can sound like a loud explosion. This was a major reason why the Concorde was banned from flying over many populated areas, forcing it to stick to routes over oceans. The problem with hypersonic jets is that their booms are even more intense, making it harder to gain approval for them to fly over countries with tough noise regulations. For countries like the United States and those in the European Union, noise pollution is taken very seriously. Aviation authorities in these regions have strict policies to limit the impact of loud aircraft. Even NASA is working on its X-59 program to make supersonic travel quieter, but adapting that technology to hypersonic jets is a completely different challenge. Until there are breakthroughs that can make these aircraft quieter, many countries may not approve them for use, especially over land where the noise could disturb millions of people. The noise problem isn't just about human discomfort. It also affects wildlife, particularly in areas where aircraft fly over national parks or wildlife reserves. Loud sonic booms can disrupt animal behavior and habitats. Environmental groups in places like Australia and Canada, which value their natural ecosystems, are likely to push back against the use of hypersonic jets. These countries may have the airspace for long-range flights, but their strict noise regulations would make it tough for such jets to operate there. Apart from the noise, the heat generated during hypersonic flight adds another layer of complexity. When a plane travels at speeds above Mach 5, it faces temperatures as high as 2,500 degrees Celsius, which is much hotter than the melting point of most materials used in traditional planes. This heat not only poses a safety risk, but also increases maintenance costs. The seating capacity of hypersonic jets also limits their appeal. With designs accommodating only a few passengers, these planes would target a niche market, leaving most of the public out of the equation. Combined with noise restrictions, this makes their commercial viability questionable in many countries. Future of aerospace. China's hypersonic jet changes the game. Since China's announcement of their hypersonic jet, Nanchang No. 1, and its crazy features, other nations have been thriving hard and looking for possible ways to match up with this new technology. This is not something China just came up with overnight. It's something that took careful planning, analyzing, studying, and testing. They did all these because they wanted to achieve the best, and from the look of things, they are on to it. Before this, other nations had been focusing on supersonic aircraft, but now the competition has been intensified again. It is not the speed of Nanchang No. 1 that makes it top-notch. Every detail about this aircraft is massive. And trust China when it comes to creativity, technology, and innovation, they always have it right. What exactly are these details? And how are other nations leveling up to this? Keep watching to find out. Let's start with its speed. The Nanchang No. 1's design is its extraordinary speed. The aircraft will cruise at Mach 6, which means it will be traveling 6 times faster than the speed of sound. That's huge. To put that into perspective, Mach 1 is the speed of sound, which is roughly 767 miles per hour, that is 1,234 kilometers per hour. Mach 6 is a staggering 4,600 miles per hour, which is 7,400 kilometers per hour. At such speeds, a journey that would normally take many hours could be completed in a fraction of the time. For example, a flight from New York to London, which currently takes around 7 hours, will be completed in less than an hour. The key to achieving this incredible speed lies in the aircraft's cutting-edge engine system, known as the mutter engine. Mutter stands for multi-ducted twin-turbine ejector ramjet, and it combines several different types of propulsion systems to allow the Nanchang No. 1 to operate at both lower and extremely high speeds. The engine design is intended to ensure smooth transitions between these different modes of propulsion, helping the jet maintain stability and efficiency throughout the flight.
Very high-speed jet propulsion with no moving parts, and they're called ramjets. They've been around for a long time, but to make a practical ramjet, which is lightweight, durable, and powerful.
The development of this technology has been years in the making, with extensive computer modeling and small-scale prototypes providing crucial data. It is also designed to use turbofan engines for takeoff and low-speed flight, rocket engines to boost the jet to supersonic speeds, and ramjet engines to maintain hypersonic speeds. In heat management, there is this challenge of propulsion. Hypersonic jets require engines that can function at both subsonic speeds that are below the speed of sound and hypersonic speeds. The Nanchang No. 1 jet relies on a combination of turbofan, rocket, and ramjet engines to achieve its incredible speed of Mach 6. Each engine type plays a role in different stages of flight. Turbofan engines are efficient for lower speeds and can operate during takeoff and landing. As the aircraft accelerates, the ramjet and scramjet engines, which are air-breathing engines that use the high-speed air intake to compress the air needed for combustion, will take over, allowing the jet to push beyond Mach 5. Ramjets are a type of air-breathing engine that becomes more efficient the faster the aircraft moves.
Ramjets only work when you're going really fast, like Mach 3.
But they are unable to operate at lower speeds, which is why the jet also relies on the other engines during takeoff and landing. The rocket engine helps to bridge the gap between supersonic and hypersonic speeds, allowing the Nanchang No. 1 to accelerate smoothly through different stages of flight. This multi-stage propulsion system is one of the most advanced ever developed and has been praised as a significant breakthrough in aviation technology. When the aircraft was initially tested, it was very promising. The smaller, unmanned prototype weighs only 500 kilograms and has already demonstrated the capability to reach high speeds in lab conditions. It will start operating fully in 2025 as the year is almost over. This jet will be in operation for decades, transporting passengers around the globe at unprecedented speeds. According to reports from China, the aircraft will be able to carry up to 10 passengers, making it ideal for high-speed business or leisure travel. The development of the Nanchang No. 1 has been led by Yin Zheyong, a leading scientist in the project. Yin and his team began working on the concept in 2019, and despite the challenges they have faced, they remain optimistic about the jet's potential. Yin has described the project as a breakthrough in both technology and travel, emphasizing that hypersonic flight could change the way people think about global transportation. Lin is a director of science and technology with the Aero Engine Corporation of China, and has even gone so far as to suggest that this new form of travel will change human civilization. The Nanchang No. 1 is widely seen as a direct rival to Concorde, the legendary supersonic jet that was introduced over 50 years ago and retired in 2003. The Concorde had a maximum cruising speed of Mach 2.04, or we should say 2,179 kilometers per hour, making it twice as fast as the speed of sound. Although impressive for its time, the Concorde's speed is far surpassed by the Nanchang No. 1, which is designed to fly at 3 times that rate. The Concorde's retirement in 2003 left a gap in the market for high-speed air travel, but advances in technology are bringing the dream of supersonic and hypersonic travel back to life. Several companies and countries are working on projects that could revolutionize the aviation industry, with speeds ranging from Mach 1 to Mach 6 and beyond. But the Nanqiang No. 1, as the name implies, really stands out in all of these. The project is one of the most promising efforts to push the boundaries. It will not only change the way people travel, but also open up new possibilities for scientific research, military applications, and space exploration. The ability to travel at hypersonic speeds would allow for faster global travel, quicker transportation of goods, and new opportunities for international collaboration. The Nanqiang No. 1 is a great leap forward in aviation technology. Its success is paving the way for the development of even faster and more efficient aircraft in the future. As the world becomes more interconnected, the demand for faster travel options will only increase, and hypersonic jets like the Nanqiang No. 1 is the answer. The development of the Nanqiang No. 1 is an exciting and groundbreaking advancement in the world of aviation. But China is not the only one trying to introduce something new. Other countries are building their own jets and aircraft. The whole features and plans are all thrilling. Stay tuned so we can see what these guys are up to. Other countries attempt to beat up Nanqiang No. 1. The race to develop hypersonic aircraft has caught the attention of many nations and private companies across the globe, all of whom understand the potential of this technology, and they are all trying to build up the best. Companies like Hermeus, Stratolaunch, and Hypersonics are leading the charge in the United States and Australia, with each taking different approaches to overcome the unique challenges of hypersonic flight. Other countries like Russia are also heavily investing in similar technology, with the aim to build the fastest aircraft the world has ever seen. The international competition to achieve reliable hypersonic travel or military applications is serious, and this next frontier of aerospace engineering has sparked a global technological race. Hypersonic aircraft, which travel at speeds exceeding Mach 5, as said earlier, which is 5 times the speed of sound, present incredible possibilities for both commercial and military applications. In the commercial sector, this technology could revolutionize air travel, making it possible to fly from one side of the globe to the other in just a couple of hours. The time-saving implications for business, tourism, and international travel is what makes it more intriguing. Long-haul flights, which currently take up to 12 hours or more, could be reduced to a matter of minutes. These advancements could make the world feel much smaller, improving global connectivity in ways we never thought possible. In the military and defense sector, hypersonic aircraft are seen as game changers. They serve as delivery systems for weapons or provide new capabilities in surveillance and reconnaissance. The extreme speeds make it difficult for enemies to detect and respond, which is a significant strategic advantage. Some experts believe that hypersonic missiles, for instance, could outpace missile defense systems, giving countries that develop this technology an upper hand in modern warfare. The technology behind hypersonic flight is complex, and developing aircraft capable of sustained hypersonic travel involves overcoming significant engineering challenges. So these guys are putting in a lot of work to make sure everything comes out well. The speed of these jets generates immense heat due to the friction of air molecules against the aircraft's surface. Managing this heat and preventing structural damage to the aircraft are two of the biggest problems engineers face. For example, temperatures can soar to over 1,500 degrees Celsius, which is 2,732 degrees in Fahrenheit, at Mach 5 and beyond. Traditional materials used in aircraft construction can't withstand such heat without compromising the safety and integrity of the jet. This is why companies like Hypersonics are researching new materials, such as ceramic matrix composites, which are lightweight, heat-resistant, and capable of handling extreme temperatures. These advanced materials are important for the success of hypersonic travel, as they help reduce heat and protect vital components of the aircraft. One of the key players in this global race is Russia, which has been making significant strides in developing hypersonic weapons, vehicles, and jets. Russia's Avangard hypersonic glide vehicle is designed to travel at speeds exceeding Mach 20, making it nearly impossible for missile defense systems to intercept. Russia has also developed the Kinzhal hypersonic missile, which can be launched from fighter jets and reach Mach 10. These advancements have sparked concerns among military analysts, as hypersonic weapons could definitely change the landscape of modern warfare. Meanwhile, the United States is also heavily investing in hypersonic technology. In addition to the efforts by private companies like Hermes and Stratolaunch, the United States government, through organizations like the Defense Advanced Research Projects Agency and NASA, is funding research into hypersonic propulsion and materials. Defense Advanced Research Projects Agency's hypersonic air-breathing weapon concept is a notable project aimed at developing hypersonic cruise missiles for military use. NASA, on the other hand, is interested in the civilian applications of hypersonic technology and is working on the X-59 quiet supersonic transport.
Now, NASA and Lockheed Martin have unveiled what they call the next generation of supersonic aircraft. The makers say the experimental plane combines supersonic travel with low noise. The public got the first glimpse of the new X-59 research plane at Lockheed Martin's Design Center in California.
A supersonic aircraft that could pave the way for future hypersonic planes by reducing the sonic boom, one of the key barriers to civilian supersonic and hypersonic flight. Beyond military and civilian aircraft, there is also potential for hypersonic technology to play a role in space exploration. Reusable hypersonic vehicles will be used to launch satellites or other payloads into space more efficiently than current rocket technology allows. For instance, Hypersonics' plan to develop the Delta Velos orbiter, a hypersonic vehicle for launching small satellites, is a significant step forward in space launch technology. This will make space access more affordable and frequent, enabling a new era of space exploration and commercial space activities. The hypersonic race is not just limited to a handful of countries. Europe is also investing in this technology. With projects like the French VMAX in full, we call it Vehicle Maneuvering Experimental, which is aimed at developing hypersonic weapons and aircraft. India has also shown interest in hypersonic technology, working on the Hypersonic Technology Demonstrator Vehicle, a program with the goal to create a hypersonic missile for its military.
Major milestone in the Make in India story. Indian scientists have successfully tested hypersonic technology.
Despite the progress being made, there are still many challenges to overcome before hypersonic jets and aircraft become a common feature of our skies. Hypersonic flight promises to revolutionize aviation, but the road to achieving it comes with technical and economic challenges. That's what has been holding this whole thing.
Well, imagine this, flying from Tampa to China, Australia, or anywhere else in less than an hour. Flight engineers at the University of Central Florida are figuring out the secret to safe hypersonic travel.
While the idea of flying from New York to Tokyo in under 2 hours is quite exciting, this technological breakthrough comes with its own set of difficulties. These challenges range from its costs and regulatory obstacles to fundamental issues in physics and the material. Let's address the elephants in the room that we can't ignore. You really should know what has been holding this whole massive project in all nations, so we don't just blame them for not pushing this innovation too fast, the way we might all want it. Disturbing challenge countries faces in tackling all this innovation. The most immediate obstacle to hypersonic travel is its cost. Developing even a prototype of a hypersonic aircraft is extremely expensive. Creating a jet capable of sustained speeds above Mach 5 requires advanced materials, sophisticated engines, and innovative cooling systems, all of which come at a premium. The amount of research and development needed to bring such an aircraft to market caused billions of dollars. That is way too much. Then there's mass production. Building just one hypersonic prototype could be tens of millions of dollars, but mass producing these aircraft for commercial use would require a global-scale industrial effort. This would involve specialized factories, high-end manufacturing processes, and an unprecedented supply of advanced materials. Costs will all trickle down to ticket prices, making hypersonic flights prohibitively expensive for all but the wealthiest travelers. While companies like Hermes have set goals to lower these costs through reusability, we are still a long way from making hypersonic travel affordable. Let's not forget operational expenses. Hypersonic jets will consume immense amounts of fuel. Moreover, regular maintenance would be significantly more expensive than that of current commercial jets. For example, managing heat damage caused by the friction of air at Mach 5 or beyond will require more frequent inspections and costly repairs. Even if an airline could afford to buy these jets, the ticket prices will likely be too much. Some estimates suggest that a single flight on a hypersonic passenger jet will cost upwards of $100,000 per seat. That is totally crazy. Why spend so much of that money on traveling? No matter how wealthy one may claim to be, there are certain things that are just too much. Not that you can't remove such an amount of money. But is it really worth it? Well, there are people who will still go for it. What do you think about this technological breakthrough by China? Let us know your thoughts in the comments section. Do not forget to like this video and subscribe to our channel. Click on the next video displayed on your screen. You will enjoy it.